Hello guys, I am Varun Kulkarni and in this video I will be speaking about neuromorphic computing. I will start by defining what neuromorphic computing exactly is. So neuromorphic computing is a type of computing which is inspired by the structure and functioning of human brain. The architecture of neuromorphic computing consists of artificial neurons and synapses, neuromorphic sensors, data converters, and interconnects. The architecture of neuromorphic computing consists of several neurons which are connected in parallel connection with each other. Each neuron receives an input signal from every other neuron. When the neuron receives an input signal from other neurons, it generates a burst in electric activity, and this burst in electric activity is transmitted to other neurons by the medium of synapses. The synapse also helps in modulating the electrical signal which has been transmitted from one neuron to another, as a result of which the neural network in the neuromorphic computing is able to learn. The neuromorphic sensors are the sensors which convert the real world data into electrical signals, and these electrical signals are further fed to the network of neurons and synapses. The data converters are used to convert analog signal to digital signal and also digital signal to analog signal. The interconnects are used to connect various components of neuromorphic computing together. The hardware implementation of neuromorphic computing resembles the neurons and synapses of the human nervous system. The artificial neurons and synapses in neuromorphic computing are made up of analog as well as digital circuits in order to receive the input signals as well as to generate the output signals. The advantage of using analog as well as digital circuits is that neuromorphic computing can operate in analog computing as well as in digital computing. Analog computing involves the use of continuous signals, whereas digital computing involves using discrete value in sequences of ones and zeros. The software used for neuromorphic computing is of two types. Number one, for simulating neuromorphic system. Number two, for training neuromorphic systems. The software for simulating neuromorphic systems is a software which is used to create the neural network models. So Neuron and Brian are a few examples of softwares which are used to create neural network models. The software used for training is a software which trains the neural networks and then runs them on hardware. So TensorFlow and Caffe are examples of such softwares. The fundamental difference between neuromorphic computing and neural networks is that, unlike neural networks, neuromorphic computing implements neurons on physical level. But at the same time, neuromorphic computing also consists of neural networks. Spike neural networks, also known as SNNs, are the neural networks which are being heavily used for the purpose of neuromorphic computing. Spike neural networks are traditionally different from the traditional artificial neural networks in the sense that they work by generating spikes to transmit information from one neuron to another, whereas the traditional artificial neural networks use continuous activations and backpropagation to transmit information from one neuron to another. The spike in the spike neural networks are generated when the internal membrane potential of a particular neuron reaches a certain threshold value, upon receiving the input signal from other neurons. Spike neural networks are useful for analog computing, and thus they are being used heavily in tasks such as speech recognition. A few examples of chips which have implemented neuromorphic computing are: number one, IBM True North chip. IBM True North chip is a chip which has been developed by IBM, and it consists of 1 million neurons and 256 million synapses. Number two, Intel Loihi. It is a chip designed by Intel. It has 130,000 neurons and 130 million synapses. Number three, Neurogrid. Neurogrid is a chip which has been designed by Stanford University. It has exactly 16 analog neurons and 512 synapses. So this is what I have spoken about neuromorphic computing. If you have liked this video, do give it a thumbs up, comment, share the video, and do subscribe to my YouTube channel. I will be coming up with more informative content on electronics, embedded systems, theoretical computer science, and pure mathematics. Stay tuned. Thank you.